Hi and welcome. In this video I will explain how you can make your smartphone or computer or power tool batteries not have to be replaced after just a couple of years, how to prolong their durability. I will also explain the differences between voltages and capacity and power. For example, answer the question why some Bosch tools were sold as 10.8 volt and then they said we're switching to 12 volt and it's all compatible. Is that some magic or some super technology or something else? It's something else. And about some manufacturers that have changed their power tool designation from 20 volts to 18 volts and similar. So explain those differences in details, and this video will have a table of contents so that you can skip to the parts of interest, but I will try to explain everything in a clear layman terms so that you can understand it without any prior knowledge. I have already made a video explaining the differences between voltage, current and power. I will make it pop up in your top right hand corner if I don't forget when I upload this. It's not necessary, but I would recommend that you watch that video. It's not very short, but it will help you understand this even better, and my goal is to explain this so that you understand why not just do this, do this, do this. That's like parrots. This is, I think, better and it stays with you longer when you really understand it. The basic and main points that I will be talking about today are here. I will explain the difference between open and short circuit connection. That's very important. Capacity, voltage and power, how they are how to say connected and what are the differences, what the differences are. Sorry about my Tarzan English. Differences between inline and parallel connections of batteries and cells, and I will discuss durability in terms not just having your phone last for 10 hours instead of only 7, but having your battery last for 5 years instead of only 2 or 3. That's what I mean by durability. Let us begin. Let's first talk about battery cells. This is a AA battery cell. I've marked the minus part with some black marker so that you can see it better and understand. I will use this as a placeholder for any kind of batteries, and I will mostly be using lithium-ion batteries and discussing them, but the principles are the same for all other modern batteries and even for older like lead or nickel-cadmium batteries, with some differences and nuances that I might mention if I don't forget, but I'll be concentrating on the, let's say, contemporary modern technology that we use today mostly. So a battery cell, this is one battery cell, I can have several of those, has a certain voltage and a certain capacity. For example, if we take the Samsung INR 21700/40T battery cell that is inside of this, for example, it has a capacity of 4000 milliampere hours and nominal voltage of 3.6 or 3.7 volts depending on who you ask, with the limits that you should not discharge it below 3 volts. When you keep discharging it, it also loses the voltage. The voltage drops, and when it drops past a certain point, the chemical processes inside the battery that create voltage and are recreated, refreshed when you recharge rechargeable batteries. If you go below a certain voltage, you might cause some permanent damage and destroy your cell. Smart appliances and chargers won't let you either drop below a certain voltage, the appliance will go down, shut down, and they will not let you exceed this. Those cells that I mentioned have a maximum safe voltage of 4.2 volts. If you exceed that, you will get some heat, maybe damage, bursting, burning, catching fire and similar. So smart high quality chargers will prevent that. But the nominal voltage that we will use is some sort of average. Let's say will be 3.6 volts. So we have that, and we have the capacity in milliampere hours. That cell I mentioned has 4000 milliampere hours. That's 4 ampere hours, if you like, and that means that if you use the current of 4 amperes, it will give you 1 hour of voltage. After that it will be drained. From fully charged to drained it will take 1 hour. If you take only 2 amperes of current, then it will be giving you voltage to run your tools for double the time, so it will last for 2 hours because it has 4000 milliampere hours or 4 ampere hours. So that's basically the capacity of a cell. Now it also has a maximum current that it can provide. So if you want to use a higher power, you can use more current, but it will not last as long. This one allows you to take 35 amperes for a longer period, or about 45 if you control it for heat. And that's a bit more nuanced. I won't be going into that, not in this video. Now, for the connections, when I hold the battery like this in the air, the resistance of the air between the minus part and the plus part is infinite. So there's no current going through it, it's not discharging. It's oversimplified, I know. I won't be going into nuances further than that in this video. So it's infinite resistance, open circuit, if you like, it's not closed. If on the other hand I do the opposite and I take a wire and connect the plus and minus directly with one wire, wire has zero resistance, in that case the current that will flow, because there's no resistance to the voltage, the current will be in theory infinitely high. It will not be, of course, infinitely high, but it will be high enough to burn the wire and probably cause the battery to overheat or catch fire or explode. So you don't want to short circuit it. The simplest way to short circuit this one would be to take some calipers and try to measure how tall it is with metal calipers. It will create a short circuit, and that's not something that you want to do. In normal use, of course, we don't use the short circuit. We keep it open until we start using it. Then we connect an appliance on our battery that has some resistance, and we run it. The voltage allows the current to flow and to run the appliance. We usually have a switch to turn it on and off when we install a battery into an appliance, and let's draw a switch here. So this is a switch, it's open now. If I close it, the current will start flowing and our battery light or drill or phone will start working. Now, what about, I've discussed the open short and capacity, voltage and power. Now we will discuss inline and parallel, which is pretty much, how do I say, entwined with the second point. So for example, if I take these 3 batteries and connect them one next to one plus to the minus of the other one and connect them like this in line, that is what I drew here. In that case, all their voltages will add up, and if we use our lithium-ion cells, we will get 3.6 volts times 3, so we'll get 10.8 volts voltage at the opposite ends of the battery, or our battery set, battery pack, if you like. So we will get 10.8 volts. Now, we could also, in that case, the voltage will be 10.8 volts, and with our 4000 milliampere hour batteries, we will have the capacity of 4000 milliampere hour, because when the current flows, it flows through all of the 3 batteries, and so our capacity will be 4000. We will only be able to get 1 ampere hour for 4 hours or 4 amperes for 1 hour. No longer than that, but at a 10.8 volts voltage. That's important, we'll get to that. On the other hand, we could connect them in parallel. That means that we connect all the minus ends together and all the plus ends, and then on those ends we put our appliance. In that case, voltage will be the same as each cell, so 3.6 volts. The voltage will not be adding up, but we will get triple the capacity, because when current flows in this circuit, if we have 4 amperes, let's say 3 amperes flowing through the circuit, it will be taking 1 ampere from each battery, because they are all combined, they are connected in parallel. You can imagine this, visualize it as water pipes, their thickness and connecting them. That's for me easiest to understand. Voltage could be regarded as pressure and current as the thickness of the flow, how much water is flowing at any certain time. Now, what about this one? Well, if you compare these two, it is the same picture, just drawn differently. What basically happened here is we took a linear connection, but connected it so that it takes less space. So instead of making this be very long, what we did is we did this. So if I compare it with just 2 batteries, instead of connecting them like this, I just set the plus and minus together, and then we have plus and minus on the other end to connect our appliance. If we want to add more voltage, we add the third one also, so that it continues from plus to minus, and then we have a plus end and the minus end at opposite sides, and we can connect our appliance. That way we have the inline connection, but taking less space. That is exactly what we have in this little baby. This is Bosch, it says 12 volts. And now you can understand why it says 12 volts instead of 10.8. They said, okay, 10.8 is not good for marketing. Yes, the nominal voltage is 3.6, but everyone else is selling 12 volts. People think that's better. Let's use the maximum charge voltage as for our marketing, as all the others did. And so now, for the past 10 years or so, Bosch 10.8 volt tools and batteries have become 12 volt. It's the same, just a different name. So that's exactly what we have. Opa, sorry about the minor accident. That is exactly what we have here. The 3 battery cells are packed inside of this. It has a triangular base, so that's what we have here. However, we can use the inline connection with higher voltage, but also increase capacity further if we take 2 of these packs and put them together in parallel. So if we regard all this, as far as the electricity goes, our appliance sees that it gets the positive voltage and negative voltage on ends. It doesn't know, it doesn't care what's inside here. So we can take one of those packs and connect it in parallel with 1 or 2 more packs. So we can put one here and another in parallel and a third one in parallel. So if we say, to try to visualize it better, let's say I'm only using 2 batteries in line. So I have this, and now I want to make it smaller, and I want to make another one in parallel. That way I will be using also the same principle. So now I got 2 packs of batteries that are in line, and I can connect them, put them like this, for example, stack them like this, and just make sure to have the proper connection so that both plus sides and both minus sides are together and not short-circuited. If I connect 2 plus sides, nothing will happen. The voltage is plus and minus. I cannot connect directly plus and minus. That's when I get short circuit. So that is exactly what Bosch did with this 12 volt or 10.8 volt 4 ampere hour battery, as opposed to the 2 ampere hour pack. They just took this that fits into small space and made another package, but in this case they put 3 batteries just lying sort of next to each other, just like this place. So they put it down. You can even see the contours, and that's what they did. And they connected the proper connections and made the higher capacity battery with the same voltage. That's for the small tools. Now for the larger tools, you want to have a higher voltage. I will explain first using the 10.8 volt set why the more powerful tools have higher voltages. Here, for example, if we want to take just 300 watts from a power tool or any other appliance, if we have a voltage of 10.8 volts, that will take, this is the formula, and you can see my video about electricity, current and power to understand what's going on there in physical terms, but basically power equals current multiplied by voltage, or for units watts are amperes multiplied by volts. So if we take the 10.8 volt battery, we will need just about 27.8 amperes to get 300 watts. Not considering the losses, drain and other things, it's a simplified explanation. However, if we connected batteries in parallel, then if we go with 3.6 volt voltage, we will need 83.3 amperes for 300 watts. Now 83 amperes is a huge amount of current. You need very thick wires to connect the battery to your appliance inside of it. Let me show. So if you have a small tool like this, you will need very thick wires inside to connect the motor to the battery if you have such a low voltage and such high current. So that's the catch. Also, when we talk about higher capacity, more powerful, stronger tools, they are usually packed with 5 batteries in line instead of just 3. That's not done for smaller tools because you physically need to pack so many cells. So for powerful tools it's necessary because you need more power, and to get more power you need either higher voltage or more amperes, and there is a limit of how many amperes you can get. So most manufacturers today are using 5 battery cells in line. Here I have only 4 to show you, and that is what Bosch did and most other manufacturers in this, for example. They have 5 cells, and they've also stacked them. For example, this one is 8 ampere hours and it uses 2 rows of 5 batteries. So it has 5 lined up in line, and then another stack stacked just over it in 2 rows, and that's why you get so much capacity and power. Their 4 ampere hour batteries have only 1 row of batteries, but here I will try to post a picture showing what this looks like when it's open. That is also a reason why Bosch 8 and 12 ampere hour Pro Core batteries, for example, can give you more power, not just more capacity so that you can work for longer, but they will literally give your tool more power if it can take that much power, if it's a powerful tool that can use that power, because they have 2 sets connected in parallel. So they have the 18 volt voltage, and they are set in parallel, 2 sets of batteries, so that the current flowing from either set is half. They share it half, the total current that is sent to your tool, and that allows it to give you more power at any certain time. So instead of, if you want to go with, say, you have 18 volt voltage and you want to go with 1800 watts. If you have only 1 pack of inline batteries, 5 of them, they will need to give you 100 amperes. But if you pack 2 in parallel, they will give you 50 each. Okay, I've used the wrong example because that's still too much, but you get the idea. I'm not sure about Bosch's 12 ampere hour packs, if they have 3 lines of those or just higher capacity for each cell to give you higher capacity. But those are the differences and the similarities between the capacity and power and current. So I hope I've explained it all clearly enough. Now I will discuss durability. As I said in the beginning, you don't want to overcharge or discharge your batteries too much. Generally, when you have a battery pack, you usually have a certain number of cells packed either in line or in parallel, depending, or both, depending on the set. Now your charger is usually with high quality tools and the appliances. The chargers and tools have smart electronics that makes sure that each cell is charged equally and discharged equally, regardless of how they are connected. However, it's not perfect. So when your phone says I have a 5% battery left, it could be that one of the cells is emptied to 0 and it's getting permanent damage, and the other cell is at 10% capacity. And what the tool measures in the end, the phone or laptop or your tool, what measures when you wish to check on the voltage or capacity, it will give you a sort of an average. It's never ideal. So for that reason, it's not good to let your batteries discharge below 10%. It's better to recharge them when they reach 10%. It's also for lithium-ion batteries and similar, the maximum capacity. It does degrade battery more when you charge it past 80%. And when you charge it past 90% of capacity, up to 100, it degrades it even more. So it's not a very smart idea to leave your phone on charger overnight or similar. It's better to charge it to 80, maybe 90% and then discharge it. Now what about topping up? Generally, all batteries have a limited number of charge and discharge cycles. So whenever you put it on a charger to recharge it, you've used up one cycle. It doesn't really matter if you've just been charging it for 5 minutes or for 50 minutes. It will degrade to a certain degree in terms of total charge cycles. So it is ideal to let them discharge to about 20% and recharge them to 80%. I understand that is not always practical, but when you have a choice, when it is convenient, it's better to go that way. And that's some rough guide. For example, with these batteries, they have 5 marks, so each one is about 20%, and so this one is now charged at 4 marks, and that's okay. I won't be recharging it until the second mark gets used up. Then I will not be waiting for it to say it's empty. I will recharge it just past just near the full charge, but maybe not wait for it until it's 100% charge. Not always, not if it's convenient. That's for charging and discharging. Another thing is about fast chargers. All the LED batteries, for example, they liked being charged to full capacity, so that's a difference, and they like being charged with 1/10 of their capacity, so to charge them properly it would take about 10 hours. With lithium-ion batteries and other similar technologies, modern technology, lithium iron phosphate and so on, that's not really the case, not in such an extreme way. So a couple of hours on a charger is okay, it's not too fast, but still those super fast chargers that will charge a battery from empty to full in an hour or less, they will also increase the degradation of your battery. So it is a trade-off. And those are things to look out for. I usually try to not let my batteries discharge fully, to be there when they are charging if it is convenient. Definitely not leave them overnight, at least that's not what I do. I wanted to say something else, it slipped my mind. I didn't write a script for this video, my apologies for the long-windedness. Some fires are caused by batteries being left unattended to charge, and so leaving a charger overnight or things like that, it happens to other people. That's what most people think, but I unfortunately know the stats for my city, and it does happen. So be careful, don't buy cheap, low quality chargers and batteries, and it's better to not leave them, the appliances, charging unattended, and when you're asleep it might end up in a tragic way, not just losing money and stuff. So that's something that I think it's fair to warn and note. It's all nice until it isn't. And I think I've covered everything now, hopefully. In terms of durability, those are the tips that I have, nothing more to add. So I think that's the whole video. If I forgot something, I will put it in the video description or in the first comment. And if you have any comments or questions, please use the BikeGremlin forum on bikegremlin.net. It's a lot better than YouTube for dealing with comments and for searching questions and answers later on, which is even more important. And if you like what I'm doing and wish to help me make higher quality videos, you can support my work via Patreon at patreon.com/BikeGremlin. Of course, what else? And that's it. That's the whole video. Thank you very much for watching. I hope you found this educational and informative, if not too entertaining. So again, thanks for watching. Cheers and stay cool. You thought it was over. It's not. I remember what I had forgotten. If you want to store your batteries for a longer period, it's best to store them in a room temperature or a bit cooler, but not below freezing and not hot with 30 degrees Celsius and so on. And it's best for the lithium-ion batteries and similar to be left at about 50% capacity. So don't charge them to 100% if you wish to store them for longer. It's better, they will degrade less if they are not 100% charged when you leave them, when you store them. So now it's finally over. Now really.